Okay, so now consider consider the n number of components and modified with a fixed law. Modified with the help of fixed, sorry, it's not modified with a fixed law, it's modified with a consensus formalism. Formalism. Okay. So we can write it as this equation J1 tilde equal to minus D tilde 1 1 dou C1 into dou X minus 1 2 dou C2 by dou X 1 3 dou C3 by dou X. Similarly, 1 n dou Cn by dou X. And for J2 tilde, I can write it as minus 2 to 1 dou C1 by dou X dou C2 dou X 2 3 into dou C3 into dou X. So minus 3 tilde 2 to the power of 2 to n dou Cn into dou X. Okay, so when we are continue up to the n fluxes, then the Jn tilde equal to n1 dou C1 by dou X minus n2 into dou C2 by dou X n3 into dou C3 into dou X. Then it is given as n into n dou Cn into dou X. Here in this equation there are totally n square interdiffusion coefficients are there. These are the interdiffusion coefficients, and we can write it as how many interdiffusion coefficients are required to define this whole system is n square interdiffusion coefficient. Okay, let's start deriving this dependent component and independent component main interdiffusion coefficient and cross interdiffusion coefficients by considering the dependent component equation. So we can write it as considering the first Gibbs domain equation. Equation x1 into dv1 plus x2 into dv2 x3 into to 0. When we are divided with the help of molar volume, then we can write it as okay. I have to write it as in the whiteboard only. x1 divided by Vm into dv1 bar plus x2 into divided by Vm dv2 bar plus up to xn divided by Vm dvn bar is to 0. We know that xi to the Vm is concentration gradient. Then we can write it as above equation as Ci into dvi plus C2 into dv2 plus C3 into dv3, and we can write it as Cn into dvn equal to 0. We know that so keep it this equation as it is and consider this Ci into Vi is equals to psi I. That means volume fraction. This is nothing but volume fraction. Correct? Okay. So differentiating these two, summation of Ci into dvi plus summation of Vi bar into dc is equals to 0. Equals to 0, and this is equals to 0 but by this equation, summation of Ci into dvi equal to 0. Okay, this is the equation that we got, and here we can write it as v1 bar into dou c1 into dou x plus v2 bar dou c2 into dou x plus up to vn bar dou cn by dou x equal to 0. So taking all the term towards this side and taking this dou cn by into dou x equal to one side, we can get it as minus dou x plus vn minus 1 divided by vn bar into dou cn minus 1 divided by dou cx. Okay, this is the equation that we got. Then we can write it as, write the previous equation, that is Onsenger's formalism, equation 1 j1, that we have written as minus into tilde 1n v1 bar divided by vn bar into dou cn into dou x tilde 1 2 minus 1n into, so v2 bar divided by vn bar dou c2 into dou x. Okay, so we can write it up to n minus 1 terms. vn bar, then finally we can write it as into dou x. Correct, this is the equation that we got. And remember this equation, I will write one more time. So this is over, I will write it as with adding, okay, whiteboard. I'll write one more time so that we can recognize the equations completely. j1 tilde equal to minus d11 tilde d1n v1 bar to the vn, so dou cn into dou x minus 1 to tilde 1n, so v2 bar divided by vn bar dou x up to n minus 1 term. I will write it as so it is a bar thing. Okay, so finally we can replace this whole term we can replace this whole term with a single term, that is a dependent quantity in all the variables, all the terms. We can write it as 2n dou c1 into dou x minus 2n 1 to 2 dou c2 into dou x 2n 1 into n minus 1 dou cn minus 1 into dou x. So this is j1 tilde. So in general we can write it as ij equal to so this is 1j minus so ij this is rn vj to the vn. Okay, this is the in general equation. So we can convert any dependent variables and independent variables to the another quantities. Okay, so this fixed law for the multi-component system can be applied to any of the systems. Fixed multi-component applied to ternary alloy. Okay, that is we can consider any ternary alloy such as nickel, aluminium and cobalt. It's one of the ternary system. Then by considering the cobalt as dependent quantity, then we can write it as the flux of Ni tilde can be written as minus d into, we can write it as dependent quantity as cobalt Ni and concentration of Ni into dou x, cobalt into Ni we should write it, and here it is aluminium dou Cl of aluminium into dou x, and the flux of aluminium can be written as cobalt aluminium nickel x cobalt aluminium concentration gradient of aluminium. So these are the equations, Onsenger's formalism equations applied to the ternary system. So in this equation we can consider So we are giving a two important diffusion coefficients, two type of independent diffusion coefficients, interdiffusion coefficients. Before getting into that one, I need to give a general condition for how many diffusion coefficients are required for the n number of systems. That is, number of diffusion coefficient required is n minus 1 whole square. For example, for ternary, is 3 minus 1 whole square, that is given as 4. We need to get the 4 interdiffusion coefficients. Okay, as I said, we are taking two type of diffusion coefficients, that is main interdiffusion coefficients, interdiffusion coefficient, where both are same, that is I equal to j. That means here in our example, cobalt, nickel, nickel, and dependent variable of cobalt, aluminium, aluminium are main interdiffusion coefficients. So what is the significance of this main interdiffusion coefficients? This will tells that the flux of Ni here, the flux of nickel is affected, how it will be affected by the concentration gradient of same component, that is nickel itself, that will give the by the main interdiffusion coefficients. Cross interdiffusion coefficient is given as Ij, where I is not equal to j. This will plays a very important role, and this cobalt, nickel, aluminium, and interdiffusion coefficient of cobalt, aluminium, and nickel. So this will tells that the concentration gradient of the J element is affected by the how it will be affected to the concentration flux of another component. Here this will tells that the concentration gradient of aluminium is how it will be affected to the concentration gradient of nickel, this one, whereas in its opposite case in that of the aluminium. Okay, this is the cross interdiffusion coefficient and main interdiffusion coefficients. Okay, this is all about the today's lecture, where we are seeing about diffusion, Onsenger's formalism, and two main diffusion coefficients, that is main interdiffusion coefficients and the cross interdiffusion coefficients. Thank you. In the next series, we are learning about second continuity equation. the fixed law, how it will be. So as I say in this equation, the flux concentration gradient is depends upon not only on the position but also upon the time. The fix has considered both time as well as position, and he derived the equation that is called as a continuity equation. That is, I think most of the seen this equation, dou ci into dou t, considering x term, equal to into dou x d tilde dou ci into dou x. This is the equation that we need to derive in the upcoming video lecture. Thank you.